So we discussed key spaces, right? Key spaces. What is key space? What is key space? And we discussed how to create a key space, how to create key space, and we discussed how to alter, alter or drop key space. And next we discussed how to connect key space, how to connect or change key space, right? So what is key space? Key space is a collection of tables, collection of related tables, right? So for every project we create separate key space. So to connect the key space we use keyword, use key space name. How to know list of key spaces? So describe key spaces. Key spaces is a command to display list of key spaces in Cassandra. So how to start Cassandra in Windows? So we use just Cassandra command. This Cassandra command starts Cassandra in our Windows system. How to open CQL cell? We open another command from and we type CQL sh. So describe key spaces. Key spaces is a command to know list of key spaces. In yesterday class we created batch 4. So to connect batch 4 we use batch 4. Use batch 4. So today we are going to see how to create table. So before going to create table, let's understand how many data types are presented. So data types are very important because a table is a collection of columns, right? Table is a collection of columns. Collection of columns. Each column has type. Each column has type or type of data. Type of data. So each column may has different kind of data. So while creating table, while creating table, while creating table, we specify we specify column types. Column types. We specify column types. So data types are used to specify type of data. So Cassandra has different data types. Cassandra has different data types. So ASCII data type, it is string representation of ASCII characters. Big int data type, blob data type, boolean data type, counter, decimal, double, float, inet, int, text, timestamp, UUID, and varchar, variant, collection type, and also we can define our own custom type. So this collection type again we have list type, map type, set type, and also you can define User defined data type. User defined data type. So we have all these data types. 1 minute. Yep. So we have all primitive data types. All primitive data types. All primitive data types. And also we can define collection data type. Collection data type. For a column, we can define collection data type. So list, map, set. And also we can use our own custom data type. Our own custom data type. Our own custom data type. So advantage of custom data type is, see, one column, I want to store different kind of data. In one column, I want to store different kind of data. Example, so I am storing some person details. Person details. So person name, person number, name, address, phone number, email. Next, wife details. So wife details is custom type. Again, wife has name, number, address, phone number, email, something additional, right? So this type I want to create my own type. So whatever the properties I want, I can define those properties by using create a type is another command. By using this create a type, you can create your own type, data type. You can create your own data type. And if you want to alter drop type, describe, we use other commands. Mainly create a type is used to create your own user defined data type in Cassandra. It supports all primitive types, collection types. Additionally, it providing user defined data type. User defined data type. Example, one more example. We are creating employee number, employee details, EMP details, EMP details. In this EMP details, we have EMP envo, ename, sal, gender, gender. Next, DEPT details. So DEPT details is my custom data type. Custom data type. In this custom data type, I defined DNO, DName, DLocation. Delocation. So you can create your own data type for assign that data type to particular column. So in this case, we don't require any joins operations. So you can create one custom data type for column. Okay. So this is main advantage of custom data type in Cassandra. So let's see how to create a table in Cassandra. First, connect database. Connect database or Keyspace. Connect Keyspace. Connect Keyspace. And describe tables is a command to list of tables. Describe tables is a command to list of tables. So there are no tables currently presented in batch 4 database. So there are no tables presented in batch 4 database. So to create a table, first, while explaining Cassandra, while explaining Cassandra, I said one important point. Cassandra follows Cassandra follows map of map, right? Map of map. So first map is key and value. This value is again map, right? So this value contain key value pair. Key value pair. Yes or no? So first key is column family. First key is column family. Next one, this is key equal to value. Key equal to value. So compulsory we need table name or column family name. Table name or column family name. Every table contain table name or column family name. Okay. So create a table or column family and table name. So column family is important. Create a table, column family, table name, column definition means it's a column name and column type with some options. With some options. So this is the syntax of creation of table in Cassandra. So let's create a table. So create table and emp. So here I am creating table emp no, data type is int, and this is primary key, and ename text is like a string in other languages. Sal sal type is int. Next, gender gender text. Next, department number int. Department number int. So we have 5 columns: employee number, employee name, salary, gender, department number. So it is looking like same as RDBMS table creation, right? So there is no difference. Now describe tables. Okay. So tables, it is showing default tables. Next, let's see inserting data into table. So select star from is same as previous RDBMS SQL query. So currently we don't have any data in this table, right? So there are no tables, sorry, there is no data. So it's showing only 0 rows. Okay. Next, to see how to insert the data. So instead of writing multiple inserts, I want to use single insert statement. So our column is empno, ename, ename, sal, gender, gender, and phone number. Sorry, department number, right? So values of one, employee name is Srinivas, and employee salary. Next one, employee salary, gender, and next one, department number. If gender is there. So this is our insertion. So we are inserting single record by using insert EMP. So let's export this insert EMP. This is also same as previous SQL statement. So there is no difference, right? So insert into EMP list of columns and values of list of values. So same as previous one. Let's use select star from EMP. This time we have one record. Instead of inserting one record like this, we can create a batch. We can create a batch. So here I'm inserting multiple records. I'm inserting multiple records. So four records I want to insert. So four records I want to insert. For that one, we use begin batch. Begin batch. Starting we use command is begin batch, and finally we write a multiple statement. How many statements you want? Write all the statements. Finally, apply batch. Apply batch. Apply batch. So here change the values, because primary key primary key primary key doesn't allow duplicate values. Does not allow duplicate values. Duplicate values. Does not allow duplicate values. Duplicate values. So change at least employee numbers. So change employee names. 20,000 female, department 11, 30,000 male, department number 12. So some employee name XYZ. So female 40,000, and department number 13. And next ABC 50,000, 50,000 male, department number 14. Then use this one. CQL, execute this one. That's it. Press enter. Put semicolon. Press enter. So it executed all statements at a time. Then select star from EMP. So we have 5 records. So let me first use where class to display employee number 1. Where EMP NO equal to 1. I want to display only employee number 1 details. So we are getting. I want to display department number 12 details. Department number 12 details. Department number 12. Observe what is the error we are going to get. So select query, we did not get any error, and primary key column we did not get any error. Other than primary key column, if you want access, based on other than primary key column, you will get, so allow filtering option. You have to use allow filtering option. Otherwise, it will not allow you to access or create index. So in Cassandra, you can create index for other columns or use this option to allow filtering. Otherwise, Cassandra by default doesn't allow to access data based on some filter columns other than primary key. Then use allow filtering. Just use allow filtering. Let's see, check. Give space. By default for other columns, Cassandra doesn't allow to filter. You can explicitly use allow filter or create an index. Create an index. So let's see how to create an index. Yep, you get 2 records. Yep. Allow filtering. Next, let's see how to create indexing. So creating index. Creating index. So create index department number on EMP, right? So take any name. Create D number. D number on department column. Now, first let's create index. So before create index, let's use without allow filtering. Let's use without allow filtering. So it's giving error, right? Let's create index. Let's create index. Then execute same command. Select command.
Indexing also for distribution of past details.
Yep. Mainly indexing. See, indexing generally, let's take any book. Any book. So let's take mastering C++. Mastering C++ book. So before before reading our book, we see index, right? Index gives list of topics, list of topics with page numbers, with page numbers. Example, example class, not our class, oops class, object oriented class, page number 100. So directly we go page number 100 and we start reading class concept, right? Yes or no? Same as here also in Cassandra, if you create index department number, if you internally it will create a department number, based on department number values, it will create indexes. When you use this syntax, department number, select star from EMP, where department number 11. It goes to index, checks index number, department number 12, and goes to corresponding memory location, reads the value of complete department number 12 details. Yep, it will check index. Index improves fast retrieval. So for columns we create indexes. Yep, internally it maintains same like our general terminology. Whatever the separate page they give us, right? Same. Internally, Cassandra also maintains indexing. Yep, Cassandra also maintains indexing. Then it goes to corresponding page number and reads the department number details and returns us. So here we are not seeing any difference for previous query, this one and this one. But if it is a larger data or big data, we see clear difference. We will see clear difference. This is just 5 records data, right? 5 records data. If data is huge volumes, you will see clear difference. No, we created based on department number. So department number, so department number 12, and it creates index, page number, some memory location 1, 2, 3, 4, 5. So in this memory, all the records department number 12 details is presented. Then it goes to this memory and reads all the records and returns us.
When we insert, then again it maintains.
No, insertion is happen based on key value pairs only. So it maintains memory locations. Department number 12 memory locations.
When department number is mentioned, if we enter a new department, I get 30 department. Then you create at the same time the name of the version also.
Yep, when you insert a 13 department number, so it inserts only key value pair format. Department number 13.
We have already created the indexing on this department number. So again, automatically it will create.
Yep, yep, because index is created, right? So based on index, we already created index to department number, right? Create index depart D number on employee department number column. So whatever the values you are going to insert into EMP table, automatically it maintains indexing. Then see, department 11 has two same records. All 11 departments is presented in single location. For which one? Multiple columns. Let's try to create a composite index. Not possible like it. So first let's see the syntax of index. So before creating, see the syntax of index. Yep, this is the best site to read data, Cassandra, data stats. So they provide complete end to end, A to Z. Yep. So it's saying table name, keys, column name. So it's saying keys, not key. So let's try assign one more index. Let's use different name, EMPNO D number, and let's use EMPNO comma D number, invalid request. So multiple columns are not valid. So index, see, only custom index support multiple columns. So again we need to create custom index. We can create our own index. Our own index, custom index. You can create a custom index and past use custom index. So here you can see custom index creation. Yep. Check in this how to create custom index. Yep. Primary key. If you create multiple columns, then this is called composite key. Composite key. So we have some key constants. Primary key. Primary key. If you pass two columns, two or more columns, we call this concept is composite key. Composite key. Sometimes we want to map both PAN and Aadhaar as one primary key. Then we don't want to allow PAN and Aadhaar duplicates combination. Then we can create a primary key with PAN and Aadhaar. So this concept is called composite key. Composite key. So it supports, Cassandra supports all RDBMS concepts. So that's why people are using Cassandra because almost it's supporting all RDBMS concepts with unlimited storage, fast retrieval, and normal hardware. Normal hardware. Okay. So we can drop index by using drop index, and sometimes it is never recommended to create more indexes. More indexes. It's never recommended. You can create n number of indexes, never recommended. Advantage. You are seeing clear advantages, right? You are seeing first advantage is RDBMS. It's supporting all SQL queries, and you are seeing it supports unlimited storage. RDBMS cannot store unlimited storage.
Yeah, there are some null values just you can store. Here it will remove the folder.
Yep. No, that is different one. So first unlimited storage and retrieval is very faster. We are creating indexing. Indexing we can create in RDBMS. This is not new. Indexing concept is presented in RDBMS. So most of RDBMS concepts are borrowed. So you can drop indexing by using drop index. Identifier means index name. And if you want to change alter, we can alter. And one more, truncate command. We have a drop command and truncate command. So same as RDBMS, drop and truncate and delete. So delete used to delete specified records. Specified records. Specified records. Truncate is used to delete all records. All records. So they may ask like questions like a difference between truncate, and delete. So if you specify condition, example delete condition, we use delete from table name emp, where emp enbo greater than 0. So it will delete all records, right? Then truncate table name emp, it is also deletes all records. So it is also deleting all records. Then what is the difference between delete and truncate? So in some interviews they may ask this kind of questions. If you say above definition, but if you use below syntax, both are removing all the records. So there is no difference. But main difference is if you use delete,
It only delete the data from the table and truncate is restructured.
no. Delete not deletes all records permanently. Not deletes all records permanently. Deleted records are going to store in recycle bin. So, temp location. So instead of recycle bin, temp location. It stores in temp location. We can recover. We can restore. We can restore. Truncate deletes records permanently. Deletes records permanently. So again they will ask question, what is the difference between drop versus delete versus truncate?
In drop,
So here we discuss only drop. Drop drops table permanently. Table permanently. About delete and truncate removes only records. So that's why drop comes under DDL. Drop drops table permanently. There is no schema of table. Updating data, updating data, we use update command. To modify data, we use update command. Update employee number 3. So by default, if you not use where class, it will update all employee details. To update data, we use update command. So same as RDBMS. So select star from EMP. EMP you will see. So employee number 3. Employee number 3. Salary is updated to 50,000. So let's see drop, not drop, delete. Delete from EMP where EMP NO equal to 3. So deleted. So select star from EMP. So there is no employee 3 record. So there is one rollback. Let me see rollback is working or not. Rollback is used to restore records. Hmm? Restore? Restore a table name EMP. Let me see our data stacks. So is there any revoke? Revoke is different purpose. Let me use C revoke. Revoke is used to revoke permissions. There is no rollback. Like RDBMS, there is no rollback here. There is no rollback in Cassandra. Like RDBMS, there is no rollback in Cassandra. So other commands we see grant and revoke, grant and revoke. So grant and revoke is used to give permissions. Grant is used to give permissions, permissions, permissions to users. So revoke is used to cancel the permissions or roll back or terminate permissions to users, reverse, assigning permissions and removing permissions, remove permissions to permissions of users. Yep. So CRUD operations means these are CRUD operations. So all CRUD operations same as RDBMS. All CRUD operations same as RDBMS. So let's use truncate command. Truncate table. Table name is EMP. So select star from EMP. Truncate is used to remove records.
And if we got already inserted and again we insert after delete, then it will start from 51. But in truncate, when we truncate the record, it will restructure the table and it will starting the order increment value from 1. This is even one.
That is, you are talking about.
RDBMS.
No. You are talking about this one, auto increment option.
Yes, auto increment.
Auto increment option, right? But I'm saying complete data, data level. Data level, it removes all the records.
Yes. Here
But additionally, auto increment value starts from 1.
yeah.
Yep. So I didn't discuss about auto increment. I discuss about only data. So data, if you use delete, we can delete specified records.
Yes. Very good.
But truncate
All records.
all records.
Yes. So auto increment is available in the center. No. Also there is a
Then we can create our own
yeah.
custom class.
Custom.
Yep. So let's use drop command. Drop table name EMP. So it will drop entire table structure. Select star from EMP. EMP. So it's showing invalid query. So there is no table. Unconfigured table EMP. Okay. So tomorrow class we see CRUD operation implementation using Java. Java. So tomorrow I will show you how to write Java JDBC applications. JDBC applications. So we see this architecture. So we have Cassandra server. Then we write a Java application. Java application. It may be Java application, it may be .NET or any application. So here we use driver. It may be any language. So middle we use driver and we send request to driver. Driver send request to database. So here we are going to use Cassandra. So we use concept is called JDBC. JDBC means Java Database Connectivity. Java Database Connectivity. By using this JDBC concept, we connect Cassandra and we perform CRUD operations. Okay. So that's it for today. We will meet tomorrow. Okay.